OCR Statistics Bivariate Data 1 Scatter Diagrams. This is video 1.4, which is on calculating Pearson's product moment correlation coefficient. There are several different ways of measuring correlation. One popular correlation coefficient, which measures the strength of a linear correlation, that is, how well the data falls in a straight line, is called Pearson's product moment correlation coefficient. When applied to a sample, that is represented by the letter R. When it's applied to the population, it is the Greek letter rho. For the purposes of this course, you only need to know about the sample. If you hear about a correlation coefficient without a name, then it's probably Pearson's. The value of the coefficient lies between -1 and 1. 1 represents perfect positive correlation and would look something like this with the points in a straight line. -1 represents perfect negative correlation and would look something like this. Zero means that there is no correlation. The points would all be scattered with no pattern. Something like this. If you are given raw data like this, you can use your calculator's two-variable statistic mode to find the value of R in the Summary Statistics menu. You can find out how to do this in your calculator manual or find out more help online. Pause the video now and have a go at finding the value of R in this case. You should get the answer that R is equal to minus 0.7014. If you're given a show that question, you would need to give details of the working out, and for that you'd need to use the formula. We'll come to that shortly. Sometimes you may be asked to calculate the value of R using summary statistics. For example, calculate the value of Pearson's product moment correlation coefficient for a sample with the following summary statistics. This looks daunting, but it's actually surprisingly simple, as you're given all of the formula. In this case, the number in the sample is 10. The sum of the x values is 36.9. The sum of the x squareds is 149.3. The sum of the y values is 73.6. The sum of the y squared values is 834. And the sum of the product of the x and y values is 303.4. The product moment correlation coefficient is given by this. If we expand it out and see the full formula, we get this. So you can see that the top part here is SXY, and underneath here we have SXX and SYY. These are all given in the formula booklet. We're going to look at how to find each part and then calculate R from there. It's very easy to make a mistake if you try and enter it all at once. Here we have the summary statistics that were given in the question. And here we have the individual parts of the formula that are given in the formula booklet. So we're going to use these summary statistics to calculate each part. So we have that SXX from up here is 149.3 minus 36.9 squared over 10, which gives us 13.139. And then next we're going to calculate SYY, which is given by 834, take away 73.6 squared over 10, because that's the sample size, and that gives 292.304. And then we have SXY, which is given from this formula up here, which is 303.4, take away 36.9 times 73.6 over 10, which gives 31.816. Now we've calculated each individual part, we can use this formula here. So we get that R is equal to 31.816, which remember was the SXY, over the square root of 13.139 times by 292.304, which gives a final answer of 0.513, and that's to 3 significant figures. Now here it is written out neatly. And remember that R must always take a value between -1 and 1. So it's a good way of checking whether your answer seems appropriate. It's also important to think about the fact that both SXX and SYY must always be positive, and SXY is the only one that can be negative. It's not in this case, but it can be. Maybe look back at the formula and see if you can think about why this must be. The PMCC formula ensures that any linear coding of the data has no effect on the value of R. This is a very important result. So say for example we've measured some length in centimetres and found R, and we change all our units to metres, then R will still remain unchanged, exactly what we would want. Let's have a look at trying it with the data on the next slide. So remember, this was our original raw data that we had at the start of this video. And notice here all of the X values have been doubled and all of the Y values have had 5 added to them, but yet R is exactly the same as it was in the original data. This was video 1.4 on calculating Pearson's product moment correlation coefficient. The final video is 1.5, hypothesis testing using the PMCC.